In this video, I want to explore writing equations from verbal expressions, or in other words, if someone describes a scenario, can we take variables and numbers and put them together into an equation that we can then use to solve that given equation. So the first thing we want to look at are some key words that people use to describe different operations and variables, etc. So first we can see that addition can be called plus, the sum, or even increased by. These are all different ways of saying addition. Subtraction can be called minus, the difference, decreased by. These are all different things we can use for subtraction. And then multiplication, we often hear the term the product or the word time. So all of these words are going to be keyed in, and we have to remember which types of operations these keywords are referring to. Some more, we also see that sometimes we have the equal sign, which can be referred to by the words equals, is equal to, or even sometimes just simply is, like 5 plus 4 is 9. There's an implied equal sign in there. We also can define variables. Sometimes the variable is called a number, or it could just be called a value. So we're going to be looking for those key definitions there. And then for division, we often hear the words the quotient to talk about division, or divided by to talk about division. And a few more here. Parentheses can be a tricky one. We often use the words the quantity when we're describing parentheses. So they literally say something like the quantity of 5 plus 4, and it's implied that the 5 plus 4 is happening in parentheses, or in other words, that they want to treat that as a given term. And we'll see that later on in an example. And we might even see some powers. The power of 2, for instance, could be called squared, or we also just say raised to the power of 2. This second term here is a little bit better because we can say raised to the power of any number, whereas squared only specifically works for 2. So at this point, let's see if we can try a few practice examples and see if we can put some equations together, and at the same time we'll also be reviewing solving some basic equations. So in this first example, we have the sum of a number and 3 is 7. So we're going to key in on all our key words here. So first thing I see, if I'm just going left to right, I see the key word sum. And if we look back at our list, I should know that sum means addition. So I'm going to write addition. So we have the sum of, the next key word I see here, a key phrase, is a number. And a number or a value can be represented as some variable. So I know one of the two things that are being added here is a variable. And we can really call it anything we want. We can call it x, we can call it a, we can call it n. I'm just going to call that x. So if we want, we can even, I'll back up here for a minute. I know that sum is a plus sign. I know that a number is really x, and I'll write the equation down here, x plus. And if we keep going here, we then have the phrase the sum of a number and 3. So pretty clearly the second thing that is being added is this number 3 here, so x plus 3. Our next key phrase here is this word is, and if you remember, is often refers to an equal sign. So we're saying the sum of a number and 3, so x plus 3 is equal to, and then of course the last term we see right here is the number 7. So the equation we're looking to solve is x plus 3 equals 7. And now I can simply solve by subtracting 3, and we find that the solution of this equation is x equals 4. So here's another example. I'm going to start going left to right, and I see the word the difference, and difference should immediately remind us of subtraction. So right off I know that my equation is going to have subtraction. So the key thing is what is being subtracted. I notice that the first number is the word number 14. Now when we talk about difference or quotient, the order is very important because subtracting the number first or second makes a difference. And just to kind of demonstrate that over here, clearly if I do 14 minus 5, that's a positive 9. But if I do 5 minus 14, it's a negative 9. So I have to be careful about which order they mean. And if I look here, it says the difference of 14. The first number, 14, I am always going to put first. So the order does matter. The difference of 14, the 14 is going to come first. And a number. So a number here implies the variable x is, and we know that is really implies an equal sign. So I'm going to put 14 minus x equals, and then our last term here is 5. So I'm going to say 14 minus x must equal 5. And there's our key phrase. Good. So I'll get rid of my little demonstration numbers over here. And now we have our equation. And again, just to refresh, the difference, that's where our subtraction came from, of 14 and a number x. So notice how I put 14 first, x second, because the order matters, is, or in other words, is equal to the number 5. So now we can solve. I can go ahead and subtract 14 from both sides. This leaves me with negative x, don't forget that negative sign, equal to a negative 9. I'll finish the problem over here. So we have negative x equals negative 9. In order to make that positive, I have to divide by a negative 1, because a negative divided by a negative is a positive, and we find that x equals 9. In this next example, some different terms, but again we want to write an equation. We see the first word or keyword is the product, so I should immediately recognize that product means multiplication, and instead of using the x, it might even better for us just to use that multiplication dot, because x can be confused for a variable. So first I know I have this multiplication dot that we're going to be using. So I have the product of 4 and 7, so I have our numbers 4 and 7. So I'll put first the number 4 times the number 7. Okay. Now if we continue, I then see the keyword is, which we recognize as our equal sign. And then the final keyword is a number that implies some variable which we can call x. So our final equation is 4 times 7 equals x, which we can quickly multiply and find that x, or that number they were talking about, is 28. In this example, again, we see some key phrases. The first one is the word 20. So I'm just going to simply identify, okay, we got a key value 20. I'm just going to write that down. Now what's happened to the 20? Well, the next key word says divided. That's pretty straightforward. That's our division sign. Now you can write the division symbol like this, but I often want you to get in the habit of actually writing that fraction bar, because that's what's really happening here, is we're writing a fraction. So 20 divided by, so divided by n. So here they didn't even hide it. They just said the second value is the number n. And again, the order is important here. Because 20 came first, notice that I put 20 on the top, and because n came second, I put that on the bottom, divided by the n. So the n is the one enforcing the division, that goes on the bottom. Next I see the phrase is equal to. That's a pretty clear indicator of an equal sign. So I'm going to say 20 divided by n is equal. And then our final phrase, well, what is it equal to? It's the 2.5. So I can complete my equation with 2.5. Now this is a little tricky, or we're back to solving for a variable in the denominator. And if you recall from last class, we can solve for the variable in the denominator by first multiplying both sides by the denominator, which is n. Or in other words, n over 1. And if we remember, when I multiply, this is going to give me n over n times 20 over 1. Or in other words, because multiplication and division are inverse operations, these n's are just going to divide to 1 and cancel. So if we finish the problem over here, I'm actually just left with 20 over 1, or 20, is equal to 2.5n. And now I can just divide both sides, the inverse of the multiplication, 2.5 by 2.5 on both sides. And now we can reach for our calculator, but we should be able to find that that divides to 8 equals n. In our next problem, getting a little bit more tricky. So I'm going to read left to right exactly what's happening here. I can see 3 times, and we can even break that up into 2 different statements. First I have the number 3, so I can write the number 3 and put this into our equation. Next key thing I see is the word times. This implies a multiplication, or in other words, that multiplication dot. A number is our next key phrase, which we can assume is a variable. So 3 times a variable. Still more coming though. Minus, this implies subtraction, so I'm going to write 3x minus. Well, what am I taking away? It's the 7. So 3 times x minus 7. And I keep just going left to right, seeing what we get here. Is equal to, that implies an equal sign. Put that 7 in here as well. So an equal sign, so 3x minus 7 is equal to, and what is it equal to? I can see that last number here is 32. So I'm left with a final equation. 3x minus 7 is equal to 32. Now you might be asking, well, how do I know if there's a parenthesis in there? We never saw those words, the quantity of, so we're assuming we're just taking it right as it is. So I'm just have 3x minus 7 equals 32. Now I just have to be careful to solve this according to the order of operations. So I have multiplication of the 3 times the x. I have the subtraction of the 7. I know that the first thing we have to do when solving, by the opposite of the order of operations, is deal with that subtraction. So I'm going to add 7 to both sides. And this is going to leave me then with 3x equals 39, noticing that the negative 7 and the positive 7 just add to 0. So finishing up this problem, if we're just left with 3x equals 39, all we now have to do is just do the inverse of the multiplication by 3, which is division by 3 on both sides. We recognize that the 3 divided by 3 divides to 1, and we're left with just x equal to 13. A few more problems here. Here I have a number divided by 4 plus 5 is equal to 22. So let's go term by term. First, a number translates into an x. So we'll write that new equation down here, starting with x. Divided by implies division, or in other words, means I'm making a fraction. So the x is being divided by some number. What is it being divided by? Well, it's being divided by the 4. Another operation's coming here. I can see that the next key word here is plus. And again, here's where it gets a little tricky. People ask, well, does the plus 5 go down in the denominator? And the answer is no. There was no quantity of 4 plus 5, right? That would imply that the 4 plus 5 were in parentheses and both do no division. So we're just assuming that the plus 5 here is a completely new operation. So again, if they had said the quantity of 4 plus 5, I would have put the 5 down here in the denominator with the 4. But because they just said x divided by 4 plus 5, we're taking it as it's read, and that 5 is being added completely separately. So now if we keep going, next I see the key word is equal to, so there's our equal sign. We've finished off the left side of the equation. Now I just need to figure out, well, what is it equal to? And we can see that number 22. So I know that my final equation is equals 22. Okay. So again, to solve, I have 2 operations. I have division by 4, addition by 5. I need to deal with the addition first. So I'm going to subtract 5 to both sides. And this is going to give me x over 4 The 5 and the negative 5 add to 0, so I'm just left with 22 minus 5, or in other words, 17. And now I just have to do the inverse of division, so I can multiply both sides by 4. And if we remember, I'll get this arrow out of the way here a little bit. If we remember, multiplying by 4 is really multiplying by 4 over 1. So again, the division and the multiplication of 4 divide to 1. In other words, they cancel. And we're left with x equals 17 times 4, or in other words, 68. Okay. Here's another example. And we're finally seeing that word quantity. So here's where it gets a little bit tricky. Go through this nice and slow. So first, the quotient. So I've got some division here. Okay, so I'm going to put my division bar, and this is where we have to be really careful. The first term that they say is going to go on top, and the key word here that I see is the quantity. So I know immediately I'm going to have some parentheses. There's going to be more than one term on the top because there's a quantity of something coming. And I can see that the two terms that are going to be in the top of that are 5, so 5 plus, which implies addition, and then finally a number, which we know is a variable. So going through that again, the quotient is what told me that the division bar was going to be there. Then I saw the word quantity, which implied that I was going to have something coming up that was going to be grouped into one big unit. So literally when they say the quantity of 5 plus a number, that 5 plus x is all one term, and they all want that to be in the top of our fraction bar. So then the second part, well, that's the top of it. The quantity of 5 plus a number goes in the top of the fraction. We still need to know, well, what goes in the bottom of that fraction, and that's where we can look and see that there's this number 2. So there's the second half of our fraction. We can keep going and see that we have the keywords is equal to, so I know the left-hand side of the equation is done, and then I can see that number 19, so I know that we have 5 plus x over 2 equals 19. So again, going through that again, quotient right here implied the division bar. The quantity implied that something right after that word was going to be grouped together, and what was grouped together? Well, that was where we saw the 5 plus a number. This whole thing was grouped together as a quantity and indicates then that the next number coming is going to be the bottom of the fraction, which is the 2, and then we just finished off the equation. Okay, so now I'm just going to do the inverse of the division because I know that the parentheses have to be the last thing I deal with when I solve an equation by opposite PEMDAS. So multiplication, division, divide to 1, and I don't need the parentheses anymore because there's nothing else left. So we have 5 plus x equals 38. So now I just need to subtract the 5 from both sides. And we see then, if I take this equation over here, that my solution is just x equals 33. In our last problem, we want to write, again, one more equation. Again, we're dealing with quantity. So let's go through. First, I see the word product. Immediately, I'm thinking, okay, I need some multiplication because that's what product says. Then, the key word, the quantity, comes up. I know I'm going to have something in parentheses. And I just realized, instead of that x, let's put that multiplication dot, not to confuse a variable. Okay. So the product, there's my dot, of the quantity, I'm thinking parentheses. So I'm going to put parentheses. Of the quantity of a number, there's my next keyword, a number, that's going inside the parentheses because this is coming right after the quantity, a number minus, so that means subtraction, 1. Okay, so again, product gave me the dot here. Then they said the quantity, so I put up the parentheses. Of, everything that comes after the quantity of is going inside the parentheses. So again, I'll group that. See how a number minus 1 all came right after that phrase, the quantity of, so x minus 1 goes in the parentheses. This keyword and tells me now that we're doing the second part of the product. Well, what is that second part of the product? That appears to be the number 6. Then we get that keyword is equal to. So there's our equal sign, which I can put into our equation. And what is it equal to? Well, it's simple enough. It's just this number, 18. Okay. So now I have to be careful. Because of the parentheses, because we're dealing with the quantity of a number minus 1, or in other words, x minus 1, I am going to have to distribute here, which is going to give me 6x minus 6 equals 18. So now I have multiplication and subtraction. I need to deal with the subtraction first by adding 6. Coming over here, that gives me 6x. The negative 6 and 6 add to 0, so it's just equal to 24. I can now do the inverse of multiplication, which is division. The division and multiplication divide to 1, so I'm just left with our answer, x equals 4. Okay. For your homework, I have a worksheet with a few problems I've asked you to do. I'd like you to take a look at those, and then we'll check back in on these next class.